So besides single bonds, there are multiple bonds. Pretty much specifically double bonds and triple bonds. So if I actually look at O2, so the oxygen that you breathe, one of our diatomic molecules, it is going to have a double bond because oxygen has 6 valence electrons, so it has 2 open spots to bond. So what happens is these 2 electrons are going to be shared. These 2 electrons are going to be shared, which gives me a double bond, which means they actually share 4 electrons. Which means I have 4, 5, 6, 7, 8 octet rule. 4, 5, 6, 7, 8 octet rule. So oxygen is an example of a double bond. Nitrogen gas, that's found most abundant gas in the atmosphere, N2, another diatomic molecule, has 3 open electrons. So those 2 will pair up, these 2 will pair up, those 2 will pair up. Forms a triple bond, and this should have another dot there. So how many electrons do they share? 6. So 6, 7, 8, 6, 7, 8. There again it follows the octet rule. So a double bond and a triple bond. So I have single, double, triple. Which one do you suppose is the strongest? A triple bond. It's like having 3 rubber bands holding something together as opposed to 1. So nitrogen, like in biology, we talked a little bit about the nitrogen cycle, like lightning can kind of break this apart. Nitrogen bonds are very hard to break apart. So it needs some type of energy to break those bonds. When you have a multiple bond, and there's an animation on your website that discusses this very well, but a multiple bond is going to consist of a sigma bond, at least one sigma bond, and then it's going to have a pi bond. So what happens is this is, and this sign means sigma, and this sign from math means pi. So this is a sigma bond, it's a single bond. Sigma, sigma, sigma. And when you look at a multiple bond, there's considered a sigma in the middle and then a pi bond that goes around it. So as far as this drawing goes, I don't expect you to memorize this drawing, but I expect you to know that anything that has a single bond, sigma, 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 if it's a double bond, it has a sigma and a pi. And a pi actually means that it falls on 2 sides. This is something that is microscopic, that in my classroom, unless you're looking on a computer animation, we can't see that. So we're going to look more at the Lewis structures, so single bonds are sigma, and anything with a multiple bond will have a sigma and a pi. And maybe the symbols you should know for sigma and pi. And here's the animation. I'm not gonna play it in class. It's on your website. It's under section 1. It's I think it's like 7 or 8 minutes. So during a study hall, that'd be a good video to watch. And here, I touched on this a little bit. Here's a single bond, and I'm not going to draw all the dots. Here's a double bond. Here's a triple bond, so it tells you there. The bond length, notice the length gets shorter, so it holds them tighter together. The strength depends on the distance. So when the length gets bigger, the strength goes down. So this has the longest length, and it has the weakest bond. This has the shortest length, so therefore it's going to have the strongest bond. It's going to pull things closer together. And here actually gives you just some of the numbers that go with it. So if I want to break that bond, here I need 159 kilojoules to break a single bond. I need close to 1,000 kilojoules to break a triple bond. So obviously if the strength is bigger, they're going to be harder to break apart. And here again, kind of review from last time. Endothermic means that there is energy required to break bonds. So there's more energy to start with at the end of the reaction. Exothermic is going to release energy. So a good way to show that is if I have a reaction, so let's say I'm going to take water and I'm going to break it into hydrogen gas and oxygen gas. If my energy is on this side, that means that energy is coming in. It's endothermic. It needs energy to break water apart. If my energy shows up, so if I have H2O, produces H2 and O2. This is not even balanced, but just to show you. And my energy shows up on the other side. Energy is being released during that reaction. So vocab for each of these. Make sure that you know that. And that will show up here on your last page of vocab words. So endothermic, exothermic. I do want to point out with the pi bond, if you have a triple bond in the middle, you would have one sigma bond and two pi bonds. So that's probably the last thing in that section.